Guys, welcome back to my final part in this series, and I'm gonna try to keep this one short and simple so I don't waste any of you guys' time. And if you guys haven't seen the first 3 parts, I highly recommend you check those out because otherwise most of the stuff I'm talking in this video won't make any sense to you. So please click the link in the description if you want to check those videos out. Now today we're going to be discussing 3 main applications that both relativity and quantum mechanics have in our real life. Like how have they impacted us? That's what we're going to be focusing on today. So let's get into it. The first application we're going to be discussing is GPS. It's something that we use on a day-to-day basis, whether we're going to a coffee store or to school or to a shopping mall, or even a road trip throughout Europe. But it's not only used in our daily lives, it's used for military purposes as well. Now, the way GPS works is that there's a constellation known as the GPS constellation, made up of 31 satellites that orbit our planet. Each of these satellites has an atomic clock on board. These clocks are basically extremely precise clocks that are used to measure time. Now, the way clocks measure time is through tick-tocks or back and forth movements of a pendulum. And some modern day clocks use a quartz crystal oscillator, which means you give it a certain amount of voltage and it starts vibrating, and that vibration is basically replacing the tick-tock movement of a pendulum. Now, while these methods may be useful to measure time on a day-to-day basis, they aren't that useful when it comes to tracking time in space. And this is also important because of the way that GPS works. Your position on Earth is calculated using 4 of the total 31 satellites that orbit the Earth. The way this is done is that the satellite will send radio waves to your phone or to any other receiver, which then bounce back and hit the satellite once again. The time that the radio wave took once it was released and then once it was received back at the satellite is measured by the atomic clock. Now, using the time that the wave took to travel back and the speed of the wave, the satellites can use those 2 values to calculate the distance. And using 4 of them, they can use it to triangulate your position on Earth. Now, say time wasn't measured as accurately as possible. Maybe it was off by 1 millisecond. Now, even that 1 millisecond could affect it so much that the final distance may be off by about 300 kilometers. That's as much as from Lahore to Islamabad. What happens with normal quartz-based clocks is that over time, they begin to measure time less accurately. After running for about a couple of weeks, these quartz-based clocks would be off by about 1 millisecond. And that could completely change your position on Earth and the satellites would be calculated. That is exactly why atomic clocks are used, because they are the most accurate clocks on this planet. Now, it is said that the most accurate atomic clock ever to be made will lose 1 second every 100 million years. The way they work is that instead of tracking the mechanical oscillations of a vibrating crystal or a pendulum, they track the naturally occurring oscillations inside an atom. These oscillations inside an atom are between the electron and its nucleus, and since they're naturally occurring, they're also highly stable. And these replace the ticking of a pendulum or the vibration of the crystal. So we know now that these satellites actually calculate the distance by measuring time. But we know from before that the theory of general relativity states that time is relative to an observer. The time measured changes based on an object's motion and its relative position to an object of mass. So this means that even though the clocks on the satellites are measuring time accurately, it wouldn't be the same time that humans on Earth are actually experiencing. It would be off by some number. This number can be calculated. We know that the Earth is rotating slower than the satellite is orbiting the Earth. So the Earth rotates at a rate of about 1,670 kilometers per hour, whereas a satellite will generally orbit the planet around 14,000 kilometers per hour. This speed difference results in a delay of about 7 microseconds every day. Now, the other part of this is that the satellite is orbiting Earth at an altitude of 20,000 kilometers above Earth. Now, the amount of gravitational pull at that height is a lot less than what you would experience on sea level or on the ground on Earth. Now, this gravitational difference also results in a time difference, but in this case, time will be moving faster for the satellite by about 45 microseconds. So when we combine the 2 effects together, we can figure out that the time calculated by the satellite would be faster by about 38 microseconds every day. So without the discovery of relativity, this effect would have never been put into calculations and GPS would be highly inaccurate. You could be sitting in Lahore and your phone will be saying that you might be in Karachi or Islamabad, or maybe even if it was so bad that maybe you would think you were in another country completely. So thank you, relativity, for GPS. The next application includes a lot of products that you use on a day-to-day basis, such as your phone, your computer, your TV, basically any electronic that has a circuit board in it. And these all contain a component known as a transistor, which could not have developed without quantum mechanics. We know from quantum mechanics that all electrons and particles have wave-like properties. The wave function, as we discussed in the previous video, describes these properties of a wave of any given particle. Now, a transistor is made up of a semiconductor. A semiconductor is a material which, at some situations, will let electrons flow through it. In other situations, it will act as an insulator and will not allow any electrons to flow through it. Within the superconductor, an electron can only occupy certain amounts of discrete energy levels. And what happens when we keep adding more electrons is that they begin to form bands or band structures, which is basically a combination of the individual wave functions of each electron and the amount of energy that each electron can occupy. Using different voltages, this band structure can be altered, allowing us to control the conductivity of the material. This way we can actually turn the conductor on or off in some certain we can basically control if it acts as an insulator or a conductor. And this on and off mechanism is basically how a computer works. When it's on, the computer will read it as a 1, or when it's off, it will read it as a 0. And this is how information is processed. By doing this, computers can now process data and thousands of lines of code, and without quantum mechanics, none of it would have been possible. Now, the last application is quite frankly the most interesting of the batch. It's one of my favorites as well. Now, this application allows us to build certain computers that are faster than normal everyday computers, like a lot faster. And these computers are known as quantum computers. So let's get into how they work. Now, ordinary, normal, everyday computers will process information in the form of bits. These bits can be in the form of 1s or 0s, and the combination of these 1s and 0s, like the different patterns, the computer will interpret those differently, and that's how most computers work. Now, the thing with these computers is that a single bit can either be 1 or 0 at any given time. It can't be both. This is because the bit is either on or off. So when it's on, it's a 1. When it's off, it's a 0. And it can't be on and off at the same time. That doesn't make any sense, does it? However, in quantum mechanics, we discussed a phenomenon known as superposition, where a single particle can take two different states at the same time. It's like the wave-particle duality. So in quantum computers, we can use this phenomenon to increase the amount of information being processed by the computer at one given time. We can change the bits to process both 1 and 0 at the same time. So a bit wouldn't be 1 or 0, it would be 1 and 0 at the same time. And the superposition bit is known as a quantum bit, or for short, it's a qubit. So say you have 2 bits in a normal computer. They can have 4 different possible outcomes: 0, 0, 0, 1, 1, 1, or 1, 0. But those are just the possibilities. In reality, you only still have 2 bits. One is the first one, and one is your second one. However, when it comes to a qubit, it can exist in all 4 possible outcomes at the same time. So instead of 2 bits, you actually have 4 normal bits. And the amount of any normal bits in a quantum computer would be equivalent to 2 to the power of n, where n is the number of qubits in that computer. But the interesting part about these quantum computers is that they don't actually help us in our daily lives. They are meant for our daily, everyday use. This is because quantum computers aren't universally faster. They aren't faster in all situations. So say you want to open up YouTube and watch a video, or browse the web, or maybe do some research, write up a document. In that situation, a quantum computer may actually end up being slower. They will only be faster in certain situations we can take advantage of the multiple qubits and the superposition phenomenon. So in a situation where there are a large number of operations to perform to get to a certain outcome, only in that situation will a quantum computer be useful. And this is because a quantum computer doesn't have an improvement in the time it takes to complete a single operation. But rather, a quantum computer takes advantage of those superpositions and it decreases the amount of time taken to complete a set of multiple complex operations. Now currently, quantum computers aren't of much use to us as they're still under development and the technology used to run these is quite complex and not yet ready to be used yet. But once they have been successfully developed, they could completely change our lives and change all industries as we know it: cryptography, medicine, pharmaceuticals, and many more. Now, back in 2019, Google tested out their quantum computer and they were able to achieve what's known as quantum supremacy. They, with their quantum computer, were able to complete a calculation which a normal supercomputer made of normal bits would not have been able to complete. The quantum computer completed this calculation in about 200 seconds. A normal supercomputer with normal bits would have taken 10,000 years to complete the same calculation, which is insane if you think about it. So in the last decade or so, we've been able to achieve so much with quantum physics. So who knows what lies ahead for us in the future. Thank you guys for watching my video and this entire series actually. I hope you guys enjoyed it, and not only that, I hope you were able to learn something from these. And once again, let me know what you guys thought in the comments below, and peace out.